Algebra 1, Lesson 32, we are looking at expressions with integer and zero exponents, and our goal is to be able to simplify those. So if we look at our rules, some big ones that we haven't talked about quite yet is the negative exponent property, where we say if x has an exponent that has a non-zero number, like x to the negative n, we can get rid of that negative exponent by putting it in the denominator. And similarly, if we have a positive exponent, we could put it in the denominator and it would become a negative exponent. And our zero exponent property says that x to the 0 power is always 1. Now we get this from some patterns that we can see. So if we have this power of 2, and we say, okay, what is the pattern every time that I change and go to a new power? So like 2 to the 4th is 16, 2 to the 3rd, 1 less 2, and we would say, oh, well, from 16 to 8, I need to divide by 2. 8 to 4, 1 less 2, we divide by 2, and we continue to divide by 2 this entire time, which means that this pattern shows us that once we get down to 2 to the 0 power, that is going to equal 1. And anytime we do this, anything to the 0 power, 3 to the 0 power is 1. 100 to the 0 power is 1. X to the 0 power is 1. Okay, and we can continue the pattern in negative exponents and say if we continue to divide by 2, that means that I'm going to take 1 divided by 2, which is the same as 1 over 2 to the 1st power. So we're putting that negative exponent, we put that into the denominator, and it becomes a positive exponent. We divide again, and we see that we are still putting that 2 to the negative 2nd becomes positive exponent when we put it into the denominator. We can also, just to reiterate this, remember our exponential form we can put into fractions or decimals, where we can say, okay, 1 over 10 to the 1st is the same as 1/10, or 10 to the 2nd is 1 over 100. Okay, and we have 1/100th. 10 to the 3rd and 10 to the 4th. Okay, these can all be shown, and really what we're doing is we have this form of negative exponents, but we just have fractions. We're dividing. Okay, so if we practice, when we write these numbers in standard form, we could say, all right, 10 times 10 times 10 times 10, all those 10s, that's 10 to the 5th, which is the same as 1 with 5 zeros. Okay, we have 100,000. Or 10 to the 4th is 10,000. All right, 1 over 10 squared is the same as, well, 1 over 100, which is 1/100th, which is 1.01. Or 10 to the 0 power is always 1. Always 1. Okay, so let's practice with a couple things with variables. X to the negative 3rd power, remember we can put that underneath 1, and we see that our solution is 1 over x to the 3rd. We can take this y to the negative 4th and put it in the denominator. The x to the 2nd doesn't need to go anywhere because it has a positive exponent, so we're good there, and we just have 1 over x squared y to the 4th. And to get rid of this negative exponent, if it's in the denominator, remember we can put it in the numerator and get w to the 4th power. Okay. So if we evaluate each expression for a is -2, b is -3, well, we can say b to the 0, I'm going to simplify first. B to the 0 power is just 1, so a squared times 1 is just a squared, which really we have -2 squared, which is just 4. Okay, so simplify first before you go ahead and put things in. It makes your life a whole lot easier. Okay, let's try it again. Okay, with 3 times b to the negative 3rd times b. Well, let's simplify and say I'm going to, when I'm multiplying things with exponents, I add the exponents. So I have 3 times b to the negative 2nd, since this is a 1st power. And that b to the negative 2nd is really 3 over b to the negative b squared. Okay, because I put it into the denominator to get rid of the negative exponent, so we have b squared. So I can just plug in my numbers, and I have 3 over negative 3 squared, which is 3 over 9, which is just 1/3. Just 1/3. Okay. Remember our rules for our normal quotients or multiplication. We need to make sure that we subtract when we're dividing. So this one, x to the 7th divided by x to the 3rd. We are going to get x to the 4th when we subtract those exponents. Or x to the 3rd divided by x to the negative 2nd. 3 minus a negative 7, that means we're adding 7. So we get x to the 10th. And this last one, a little bit more complicated, but we go variable by variable. Or we can move and get rid of those negative exponents, which I would actually do that way first. So getting rid of the x to the negative 5th, I'm going to put it in the basement. And z to the negative 3rd, I'm going to put it in the attic. Okay, so we get y to the 6th, z times z to the 3rd over x times x to the 5th times y squared. Now when I multiply out, I get y to the 6th, z to the 4th, and x to the 6th, y squared. And the only thing I have to do is get rid of the y's that are in common. So I end up with y to the 4th, z to the 4th divided by x to the 6th. And then you can see this other way to do it by just subtracting. So there's multiple ways to do it. Just one more example. The intensity of sound can be measured in watts per square meter. The table below lists intensity levels for common sounds. So things like rocket liftoffs, jet liftoffs, loud music, vacuum cleaners, regular speech. We can see all of those expressed in power form, okay, exponent form. So how many times more intense is the sound of a rocket liftoff at 10 to the 3rd watts per square meter than that of regular speech at 10 to the negative 7th watts per square meter? Well, what this is saying is how many times more intense? So how many times can I get 10 to the negative 7th into 10 to the 3rd? Which really is just division. We have 10 to the 3rd divided by 10 to the negative 7th. Which when we subtract, we have 10 to the 3 minus a negative 7, which we add, and we get 10 to the 10th. Okay, 10 to the 10th more times more intense, which means if we put it as a decimal, we're going to have a 1 and 10 zeros, which means that when we name this number, this is 10 billion. 10 billion times more intense. That's a lot. That's a ton. Here are some other practice problems that you could do, okay, like x to the negative 5th, this is the same as 1 over x to the 5th. P to the negative 8th over q to the 4th, well, I could express that as 1 over p to the 8th q to the 4th. 1 over d to the negative 8th is the same as d to the 8th. And evaluate for a4, b6, c3. Well, a to the 0 is just the same as multiplying by 1, so we have bc squared, which is, b is 6, so we have 6 times c squared, so 3 squared, which is 6 times 9, which is, 63? I'm losing my mind. I think that's right. No, it's not. That's not right at all. Sorry. End of the day, I am exhausted. Ignore my little math mistake. Okay, so 6 times 9 is 54. Sorry about that. Okay, and for a to the negative 2nd, well, that's just 4 over a squared, which when we do that, we have 4 over 4 squared. So 4 over 16 is 1/4. Okay, and simplifying with all of these, we get x to the 6th. Here we bring up the x squared, so we have x squared times x to the 9th, which is x to the 11th. And then here, step by step, I'm going to move the y to the negative 3rd to the basement, so we have x z to the 5th over y to the 5th, right? We have that 2 and that 3, x squared z. Now I can cancel out my z's, and I can cancel out one of the x's, right? So we have 1 over y to the 5th x. Well, I hope this is helpful for your homework and for studying.